Welcome to this episode of Canway Youth Decoded video series. Canway Youth is a nonprofit organization focusing on positive youth development, and in the Decode video series, we try to translate leading-edge science, technology, and deep insights into actionable knowledge for a young audience. I'm Alvidrez, Engagement Vice President for Canway Youth. We are privileged today to have with us Dr. Ricardo Dolmetsch, President and Chief Scientific Officer of gene therapy company uniQure. Prior to uniQure, he was Global Head of Neuroscience for Novartis. In his academic career, Dr. Dolmetsch was a professor at Stanford Medical School and a senior director at the Allen Institute for Brain Science in Seattle, Washington. He obtained his bachelor's degree with honors from Brown University, earned his Ph.D. in neuroscience from Stanford University, and conducted his postdoctoral training at Harvard University Medical School and Children's Hospital, Boston. Today, I'll be asking him about exciting trends and new directions in neuroscience, as well as what steps our younger generation should take now to maximize our health today and in the future, and how to advocate for ourselves with medical practitioners as we start taking charge of our healthcare. Dr. Dolmetsch, thank you for taking the time to be with us today.
Thanks, Ari. Thanks for the invitation.
Of course. Dr. Dolmetsch, many students in my generation seem to be affected by anxiety, depression, and other mental stresses. From your perspective as a neuroscientist, are we just catching more of these problems, or is there something about life now that raises concerns?
I think this is a particularly tough time to be a young adult, but for a very different set of reasons than have been true historically. So in the past, it's been often difficult to live in times of war or in times of famine. This, fortunately, are not problems that we have today, at least not if you live in the US. But instead, we have a whole other set of problems. And I think that we're learning that some of these things actually pose real challenges to mental health. So one of them, for example, is just the ubiquitousness of the internet and of screens. And I have come to think that that actually imposes a big barrier to mental health. It provides sort of an easy escape for a lot of people, and it has, I think it has actually taken a toll on the mental health of particularly young people who have grown up with this set of technologies. I know this is kind of an old guy thing to say, but I really do think that there are a whole series of things that people do online that end up making them feel much less good than they should. So that's one kind of thing. In addition to this, of course, we live in a highly competitive society, and that also imposes a big, that's also a problem in terms of mental health. And I see this all around me, where people are very worried, very stressed about what they're going to do in a way that I think wasn't quite true even in the previous generation. So I think these are definite issues that we just, we had before, but we didn't have them to the extent that we have them today.
Taking a step back, I'd like to ask more about what recommendations you may have about the habits, activities, and choices that help preserve and enhance personal health.
Yeah, I think everybody has to learn how to deal with their anxiety. And I think anxiety is something that affects almost everybody at some point in their life. And we all need to develop healthy ways of dealing with it. So I'll give you an example. I found a long time ago that if I do exercise and I run long distances, it really changes my perspective on my days. It helps me deal with all the stresses. And I think that is true for a lot of people, but it's not the only thing. You can, for example, find, music is something else that does this. Art also helps. So there are a whole bunch of things that can really help you deal with all these pressures. And part of what they're doing is that they're helping you get out of your own brain. They're kind of helping you deal with all the sort of anxieties that are just there and helping you be in a different space. I think developing those habits early on is really valuable.
Do you suggest running to our general audience? Is that something you're passionate about?
It doesn't have to be running. I think any kind of exercise would help. As I said, I think there is something about doing something that is a little bit hard, that is a little bit painful, that once you get going, you can kind of get into a stride. And so running does that for me, but biking works, probably playing soccer, probably there are a whole bunch of things that I think can help you do this. But I know that the same thing is true for music. When I play instruments, I also find that, as I'm playing, I'm not thinking about anything else. That I'm just thinking about that. And so I think any of these things can really help. The other thing that I think has made a giant difference in my life is actually trying to maximize the time I spent with my friends. And it's kind of interesting. When you're young, you're in a situation where you can make a lot of friends. And what we're not so good at is actually keeping those friends and actually planning times when you're with them, because I think that also really helps to reduce your anxiety and, generally speaking, makes you happier.
For sure. Going a level deeper into scientific advances that should give people hope, can you give some examples of advances in knowledge or specific therapies that pull the curtain back on things that used to be viewed as hopeless mysteries?
Absolutely. Well, there are two things that have been really giant revolutions over the last few years. I mean, one has been the advances in the treatment of Alzheimer's disease. So for a long time, we really have had no treatment for Alzheimer's other than sort of symptomatic treatments, and they don't really work very well. And this is particularly bad because we have something like 12 or 15 million people with Alzheimer's in the US today. We're going to have something like 50 to 100 million, over the coming decades, and that could really bankrupt us. And for the first time, we have a therapy that has been approved that actually changes the course of the disease. Now, it's not a cure, and it's not as dramatic as we'd like it to be, but I think it's kind of a crack in what has been kind of an impenetrable wall. It's an antibody that removes the plaques that form in people who get this neurodegenerative disease. So I think that's one really big thing. The other one, of course, is the obesity drugs. Again, we used to think of obesity as this thing that, it was sort of a character flaw. And yet we kind of knew that it wasn't. I don't think anybody who was obese or severely overweight really wanted to be that way. And yet it's extremely difficult to manage. And so the GLP-1 agonists that are going to revolutionize our treatment of obesity. And I think those two things actually provide some hope, because I think they show us that, with science, we can actually make, improvements that can dramatically change the lives of people.
Are these two drugs on the market or in the process of moving to the market or in testing phases still?
No, they're both on the market. So the GLP-1 drugs, there are two of them on the market. One of them is made by Novo Nordisk, and the other one is made by Eli Lilly. And they were originally designed to be diabetes drugs. And then people discovered that if you use them at higher concentrations, they actually allowed you to lose a lot of weight. And they seem to work in two ways. They slow down the rate at which food goes down your digestive tract so that you feel fuller, but they also seem to affect the parts of your brain that make you hungry. And that's really important for people who have eating disorders. And then the Alzheimer's drug, there's one that's already on the market. It's called Leqembi. It's lecanemab, and it's an antibody that binds to the plaques that trigger the disease. And then there is another drug that will come on the market relatively soon that is a Lilly drug that does essentially the same thing. Now, these are not, they're not panaceas. They won't work for everybody, but I think they help us. We now have a path to try and develop better drugs for neurodegenerative diseases.
And to be clear, these aren't end-all be-all solutions. Like, they don't fully combat the disease, they just slow them in most cases.
Well, that's definitely true for the Alzheimer's drugs, yeah. So they slow the rate at which you decline, but they certainly don't bring back function, and they don't halt the disease entirely. And the thing is, we now are starting to understand the genetics of these diseases in a way that we didn't understand them before. And so I think there will be a new generation that will be used in combination with this generation that I think has an even better chance of preventing kind of cognitive decline.
Some of the newer tests, such as genetic sequencing, functional MRIs, etc., are still quite expensive or not even covered by insurance. If you had to recommend a handful of things that young people should not postpone until a problem shows up in the later years, what would they be, and which are affordable and which are still luxuries?
Yeah, I think the fortunate thing about being young is that you're usually very healthy. And so I think you don't really need to be worried about some of these tests to try and diagnose hidden cancers or hidden cardiovascular disease. I guess that if I had to recommend something for somebody who's young, I would say to get into the habit of seeing your primary care physician. I'm always surprised at how few people actually have a relationship with a primary care physician when they become young adults. And it turns out that it's really important because there are lots of things that are very treatable. And you should periodically, everybody should have a checkup. And I'm always surprised that people don't have checkups. They don't go to the doctor. They don't go to the doctor for years and years and years. And by the time they catch something, anything, it's too late. So it is important to get into the habit of doing that early on.
How would you suggest to do that?
Well, I think of course, and this is the thing, the American medical system is really dysfunctional in this particular regard. I think there are, what you really need is reasonable insurance, because with reasonable insurance, then you can identify a primary care physician and then make sure that you just remember to just schedule a visit once a year and stay up on, the usual things. Because most of the things that you can do that improve your quality of life and your health are fairly trivial. There are things like, vaccinations and things like eating well and doing exercise and having somebody to talk to. And these things are the things that make the biggest difference. There is a point in your life, usually sort of sometime in your 50s, when suddenly these more invasive tests become really important. And then you have to make sure that you get screened for cancer, and you have to make sure that you get screening for cardiovascular disease. And then perhaps some of these more expensive tests are worthwhile, but they're not worth it when you're in your, 20s or 30s.
Beyond health advice, some in our audience will be interested in career advice. Can you tell us more about your path from being born in a Colombian family of artists to becoming a neuroscientist?
Sure. So it's often the case that you become something that is completely different to what your parents did. And I grew up in a family of artists. My dad is the director of an orchestra, and my mom is a human rights lawyer. And really, in my family, there had never really been a scientist. I think I became interested in science sort of serendipitously because I discovered I was really good at following directions. So I was at school, and I was suspended for writing dirty limericks in the typing class. This tells you how old I am, because we used to have to take typing, and I used to sit in the back and not actually do any typing and just write dirty limericks with my Australian friend. And when the nun who taught the class found out that I was doing that, they suspended me. And so I went home, and there was no internet and there was no television. And so what I found were a bunch of cookbooks. So I started making bread, and I discovered that I was really good at following directions. And so I thought, well, if I'm really good at following directions, I'm probably good at doing things in a lab. Again, not having ever been in a lab or really knowing any scientists. And so I kind of became fixated on the idea that I wanted to be a scientist. And then when I went to the US, I initially started studying, computer science, thinking that I had to make a living, which of course was true. But then as I was studying computer science, I started working on these very early neural nets. So before we had ChatGPT, way, way, way before, people were interested in these very early neural nets. And I was the kind of undergraduate who was doing the coding for people who had sort of grander ideas. And I thought, well, if I'm going to be working on neural nets, I should figure out how actual neurons work. And so I started working in this lab. And I found that that there were like three things that were really great about like science. One was that you had a lot of autonomy. So, I got to do a lot of my own experiments and design my own experiments. And I was super young, and I had all this freedom that I really didn't have in the rest of my life. So that was one part of it. Two, I loved this, the sense that, sometimes I was the first person to ever be doing something. the kind of the sense of discovery. And it was just wonderful when something worked. And then just the philosophy of it. I just love this idea that, you know, I mean, there's, you know, one of the fundamental questions of biology is understanding how like wet, squishy things like brains give rise to ideas and thoughts and emotions. And neuroscience, which is what I ended up studying, was getting at the heart of that issue. So that's kind of how I ended up doing that. I then, you know, I then proceeded to go to grad school. I went to Stanford and I, you know, did a PhD, and I actually worked in this immunology lab, but I also was in the neurosciences program. And I was super fortunate. Again, I arrived there thinking that I would know exactly what to do. And it turned out that I knew nothing. But I was lucky in that I landed in the lab of this guy who was, you know, up for tenure. And so he had to produce. And I was one of the few students in his lab. So he, you know, taught me how to do a whole bunch of things. And I ended up with a whole bunch of papers, which then meant that I, once again, became convinced that I was really hot. And so I went to do my postdoc. And it turned out that once again, it was clear that I knew nothing. So then I you know, did a fellowship at Harvard where I worked on, again, trying to understand how experience influences the development of the brain. I also invented some technologies for, you know, screening for small molecules for drugs. And eventually I ended up getting a job as a professor at Stanford. But, you know, along the way, of course, I failed to get lots of other jobs. So I would say that, you know, I've made it seem as if it was nice and linear. Actually, it was largely failure. But, you know, there were, you know, just the occasional successes, you know, interspersed in the failure. So yeah, that was kind of how I ended up being a scientist. And then, you know, I once I had my lab, it was amazing because I could, you know, I could work with super smart students and postdoctoral fellows, and there were just so many questions to be answered. And I became really interested in trying to understand how the brain is built and then how it breaks when people develop psychiatric diseases. And this is actually what ultimately led me to a life of making new medicines, which is what I've been doing for the last 20 years.
Throughout your career, could you pinpoint one pivotal technology that you helped innovate that you feel strongly about?
Sure. There are a bunch of things. I think the thing that I'm proudest of when it comes to technology is the technology to, so maybe just to provide some background. So if you want to study psychiatric or neurodevelopmental diseases, what you really would like to do is to study the brains or the neurons of people who have those diseases. But of course, you can't really drill a hole in somebody's head and take those neurons out. And in this way, in neuroscience is different than, say, oncology. You can, if somebody has a tumor, I can take out a piece of the tumor and study it in the lab, but I can't really do that if somebody has, say, schizophrenia or autism or something. So we were kind of pondering how to deal with this situation. And of course, we knew that many psychiatric diseases are genetic. And so we developed a technology that allows us to take skin cells or blood cells, convert them into stem cells, which are the cells that can make every other cell in your body, and then take those stem cells and make them into neurons. And so we then use this to subsequently make these mini brains, which were kind of, it was a way of getting a biopsy from somebody without actually having to get the biopsy. And then this has subsequently, you know, expanded throughout all of drug development. And so people use it routinely now for a lot of things, for safety testing, for efficacy testing, because it's a way of getting human neurons without having to actually, you know, get neurons from any human. And furthermore, the neurons have the same genetic background. So I could make, for example, your neurons or my neurons. And if I happen to have a disease, then I could actually be working on disease neurons. So that has turned out to be super valuable. So that's one thing, that's one technology I'm proud of. And then in terms of medicines, I've worked on many medicines, but I think there are two that are particularly important. One was we developed a drug to treat something called spinal muscular atrophy, which is a kind of ALS in babies, and it's lethal. And so when I was at Novartis, we worked on this drug that is a gene therapy that is, well, for some kids anyway, just basically a cure. And so there are a whole bunch of, it's now a chronic disease as opposed to a lethal disease. And then I also worked on a drug for hemophilia, which is a disease of bleeding. And there we also made a gene therapy, which is basically a modified virus that we can put into your body, and it rescues you from this bleeding disease. So those are, I would say, the achievements thus far.
Also, I'm very curious, throughout your career, do you feel like you've been able to carry any influence from your family and their professions?
Yeah, I mean, I think from my parents for sure. I mean, my parents are very creative people. And I think I realized that as a scientist, you also have to be creative. You have to think, not only are you thinking about creative solutions, actually most of the creativity is in identifying the problem. You know, what is the thing that you really need to work on? What is the thing that would make the biggest difference in somebody's life? And so I think that has definitely carried on. And of course, from my kids, you know, I have, as you know, I have one kid that has type 1 diabetes and the other one has autism. And that has really shaped what I do because I worked on stem cells, at least partly so that I could help make beta cells, which are the cells that are missing in children with type 1 diabetes. And I also worked on neurodevelopmental diseases, partly because one of my kids had a neurodevelopmental disease and I was spending all my time thinking about how to treat them. And I realized we knew nothing. And so in that way, your family has a huge influence on what you do, and certainly has had a big influence on what I do.
That's wonderful. Dr. Dolmetsch, many thanks for your time and all the great insight. For anybody who wants to get deeper into some of these topics, there's a publication in the Journal of Nature by the title Turning Point, Ricardo Dolmetsch, that goes into greater detail into Dr. Dolmetsch's early career experiences as a researcher. Thank you, everybody. Be well.
Thanks, Ari. Take
Thank
care.
you.
Bye.